Hi, welcome to another new old computer stream. And as always, I forget to close my closet door before I start, so I should go and do that now. Or my wardrobe, even. Alright. So today we continue our mission to get a sad old Lisa back into better shape. So, oh, excuse me, my dog is eating something from the ground. Stop it. I'll eat this. My room is still a bit of a mess here. So yeah, you can see I have Macs on the floor and floppy drives on the floor and all sorts of things going on. Because as I think I mentioned in the last two streams, I'm getting ready to move. So I'm getting rid of stuff and packing stuff, giving away stuff. Quick recap where we left off last time. We got as long as having a motherboard that was assembled to the point where it can be tested, and we did test it, and it worked mostly. Oh, sorry, I'm concerned my dog is eating like pieces of solder or something like that from the floor, but no, I don't think there's anything. I think I did all right. Anyway, so let's switch over to, okay, as always I need to probably switch this back and forth. There we go. To the Lisa. I think she is, it's pretty dark there. I don't know why it's so dark. I have everything turned on, but anyway, the Lisa sits over there, and the card cage is just behind her here. Here's the card cage. Oh, that is so dark. Maybe I can see if I can switch the studio lights this way. It's still kind of dark. I think I need studio light on the other end of the room, probably, to get a more reasonable lighting there. But yeah, the card cage is here. We built the motherboard that sits underneath last time. I still haven't installed the various ports, expansion slots, things like that. I usually save the non-critical parts until I know for certain that the rest of the build is fully working. And where we left off last time, it wasn't fully working because we got some errors. So the first error had to do, I think I concluded last time, with poor connectivity in the socket for the CPU card. Fortunately, what I learned is, kind of playing around with this, is I think that the material on the reproduction boards here has a lot more flex. It's not as sturdy as the original PCB that this Lisa was made with. So it has a lot more flex when you push these daughter cards into the motherboard. So it gets really hard for the edge connector here to really connect well in the slot. So yeah, we got some errors early on, like a big loud beep leading up to the first test, and then reseating the CPU card, we got it booting but then we got memory board errors. So we still have the memory board errors, unfortunately. And let's have a quick look at what that looks like. Oh, let's switch over to the camera with the card cage into the Lisa, like so. Then we need to wedge in something to hold down the switch. We turn on the Lisa. So we hear the high-pitched whine of the Lisa starting up. We should see the CRT come up soon. Here she is. So yeah, we immediately get a mem2 error. I don't know, does that show up in the feed? Yeah, I think it shows up pretty well in the feed. You see there, there's an X mark over the mem2 icon, which means that there's a fault with the second memory board, which is the outer one in the cage. And I have not been able to figure out why that is. I reflowed all of the joints in that area on the memory board 2 socket. Didn't help. Tried swapping out the memory boards. Didn't help. I know both of these boards are good. They tested good before. So yeah, something is up here. It could still be potentially that the CPU card doesn't have good enough contact in there for whenever it's trying to address the memory. We can't get the signals over somehow. Maybe the bus signal, the addressing works, but then it doesn't get the right data back. Hi Zenside, welcome to the stream. Beep beep boop. We are looking at computers. So unfortunately, there is a fault somewhere. But I'm not gonna spend too much time. Oh, hi 50 Shades. Thank you for joining. It's Elisa. I'm over here. Yeah, so if you join now, you can see that I'm demonstrating the memory board error. So yeah, unfortunately, this memory slot, the second memory board, is always failing, regardless of which memory board I put in there. So it's not a problem with the memory board, it's a problem with the circuitry between the memory board and the CPU board, probably. And since, if you recall, if you saw the last stream, we had problems with the CPU board initially. We got garbled screen and stuff all over. Had 2 loud beeps, sad Lisa. We got it booting after we put some contact cleaner and finagled the CPU board. So yeah, I think maybe I need to just rework all the joints again. Maybe I need to just put even more contact cleaner, kind of wipe. Maybe I should go with an eraser and try and really spruce up the CPU board's edge connector, see if we can get better contact. So, but I'm not gonna get hung up on this. I'm gonna move over onto the I/O board, and in order to, there, it turns off. I like the CRT, whatever it's called, decharging pattern on this the Lisa CRT. It's kind of cool. So in order to test, let's remove memory board number 2. Just lift up the tabs. Should slide out. Here. It's always a bit fiddly to get this out. Oh my gosh, why is it? Here. It's hard to do this with one hand. There we go. So yeah, if you see, it says MEM2 there. This is memory board number 2. So let's see what happens when we only have the one memory board in there, in memory slot number 1. Lisa only requires one memory board to run. So now no memory errors. It's giving us the boot screen. So by the way, this is the standard boot screen when a Lisa 2/5 or 210, I guess, don't find the profile hard drive. So it's asking for floppy drive. Let's put the floppy drive in there. Hit Command 2 to boot. This power supply is so loud. I don't know if you can hear the high-pitched whine. So now it's trying to load in the Macintosh ROM emulation, and bam, sad Mac. So that means that the motherboard didn't have anything to do with the original problem. Let's build the I/O board. Try and brute force this Lisa to work. By the way, I found it kind of neat. This is the Macintosh XL, MacWorks XL original box. On the inside, it has this really neat artwork for the Mac XL. So basically, the Lisa as expressed in the Picasso style that famously was used for the original Mac marketing material. I find it kind of neat. And when it's crashed like this, the soft power control circuitry is not responding, so you can't turn the computer on with the power button. So let's just hit the reset and let it do its test again, and then turn it off. All right. Oh, hi Eli, thanks for joining the stream. So let's, I'm gonna get my studio light adjusted again. And let's pop out the I/O board. This is what we need to achieve. So some of these parts here are handily socketed, like the ROM chips and some of the controller chips, and then the infamous COP chip. This is the most rare and expensive part, yeah, well, nowadays, and it's a bespoke part that's been emulated now. You can get an emulation circuitry for it, which is handy. But yeah, let's dive into try and replicate this board here. Lots of parts. So see if I can find a good place to put this board. Let's put it down here. And to build it, we have a bunch of chips in these tubes here. We have some D-sub connector. Well, this is for the motherboard. Some transistors, some baggies hanging around. And let's see here. Excuse me, sorry. Come here. Alright, come here. Okay, so my dog wants to make guest appearance. Oh, there she is. I'm dog sitting her. Yeah, she got a bath today. Yeah. Good. Wait. Oh. We have some more chips. Yeah, applesauce is making an appearance. There's the box of the other parts. Yeah, I'm sure. Yeah, it'll take at least an hour to solder this. I think the tricky part is to find exactly the right parts for all of the little locations, because they are not, the values are not written on the board. Excuse me. So as usual, we need some kind of strategy to identify and solder these in a good, reasonable order. I think it's generally good, I think, to work inside out. With these through-hole boards, it's not that big of a deal, whatever you decide to do. But I think I found it's kind of handy to do the small components first. So your capacitors, your resistors, your transistors, and once all of those are in place, I'll add the big caps here as well. Then we tackle the sockets. So everything, all of the ICs are going to be socketed, so that will make it easy to troubleshoot and work on it later. There's going to be a switch here, which is kind of useless because we don't have a battery. We're not going to install a battery in this one, unless Eli wants one. That can explode again. And yeah. So I think I had one. Oh, this memory board we don't need right now. Just one resistor baggie floating around with a 3.3 ohm, also 3.3 kilo ohm even. So maybe we can start with that. So I'm gonna bring up, okay, there, oh, oops, I should not be, let me see if I expose something I shouldn't expose there. Yeah, kind of. I should definitely go back and censor that out because there are people's names. So this is silly OBS. I have two browser windows open. I associated the browser share with one of those windows last time, but now it's switched over to the other one by itself. That's not cool. Yeah, do you want to see Varta? Varta action. So let's see if I can switch over to the other window. Yeah, this is what I wanted. Always tricky when you stream from your day-to-day computer. You can mistakenly expose something you shouldn't. Oh, hi Paul, thanks for joining the stream. Who is, oh, the bench is out of focus? Yeah, this Logitech webcam is not a good setup for the bench camera. I need a better setup eventually. Maybe I should it might be better. Let me try to lower this arm a little bit. See if we can get. some more usable picture. Jeez, that's not good. Look at Logitech. Look, he can't do anything right. Silly Logitech. Nope. That's why I had it a little bit higher up, because then at least I got a consistent zoom. Maybe that's better. We don't get a lot of overview, but at least we get... Okay, that kind of works. That might be better. But it's gonna be harder for me to always show off exactly what I'm working on, because I have to move this around a lot. So please forgive me if whatever I'm working on is out of focus or out of the viewport. So I'm gonna, last time I did a little bit of a sneaky thing. I did search, I just used the browser search function to find where the values were. So for instance, we have the 3.3K ohm resistor. So I search for 3.3K and we get R22 here, for instance, or R43, R41, R18, R22. Okay, so we have those four. So hopefully I have more than these two 3.3K ohm resistors. So I'm gonna switch back to the bench cam, and I'm gonna be looking at this screen over here with the info. So this is where I wish I had two monitors. Actually, let me see if I can make this smaller. See if we can, okay, so R22 is right over here. Oops. So I'm gonna do like last time, just feed a couple of components, a whole bunch of these small ones, and then solder them all in one fell swoop. I found that to be kind of handy. Let's see, move some stuff out of the way. I need a little bit more clearance to move the board around a lot. R43. So R43 is down here. Right. So I think I'm gonna fish out as many of the resistors. Oh, here we go. That's a lot of resistors. Shall we go for these 10K ohms? Let's go for these 10K ohms. All right, 10K. So for 10K, I'm gonna just pour out a bunch of these right here. Dang. Resistors. $10K for R31. So handily, oh, let's see there. We don't want to put resistors into capacitor slots. R36. R31, R36, R38. So generally the lower numbers are up here, and then we have the higher numbers as we go down. So I just need to find where 31 is. There's 34, 35, and then 31. I always try to center the component, make it look nice. Was my address exposed? Doesn't really matter if my address was exposed. I would be staying on this address for much longer. Okay, R32 is also 10K. R31, R32, R34 is 10K. Right here. R35 is 10K. And when lining resistors up like this in the same values, I make sure that they are in the same orientation, so you get nice, consistent stripes like that. R38 is also 10K. And R38 is just before 38 right here. R26 is 10K. R26. R26 right over on the other side. I'm sure there's a better way to bend these legs. It's a little bit messy. R7 is 10K. R7 should be up here somewhere. Right here. R7. R8 is also 10K. R9 is 10K. R11 is 10K. IMK 500. R12 is 10K. Right over here. And now we're at resistor packs are a different category. So we're back at R31. So I think that should be it for the 10K ohm resistors. I'm gonna put that baggie away. So I think this is a pretty nice start. They're not perfectly lined up. So yeah, if somebody has a methodology for how to make these resistors really neat, I'd love to know, but I think this is good enough. Let's move on. So here are some capacitors, but let's keep moving on the resistors, more capacitors. We have some sockets for later, sockets. Here's one very special resistor, 39K ohm. We have 1K ohm. Oh, you were talking about the Minnesota address earlier? Okay, yeah, that's DG key, not my address. 701 Brooks Avenue South, C3 River Falls, Minnesota, USA. We have some 80.6 kilo ohms. We have some 5.1K ohms, 330 ohms, some other stuff, 22K ohms, and a very special 698 ohms. We have 3.3K ohm, 680. Didn't we have 680 ohm already? Maybe two baggies. 1 mega ohm, 10.5K ohm, some crystals and stuff, 150 ohms and 20K ohms. So that should probably cover most of the resistors. Move down the line, 20K. So I'm gonna use the same trick, search for 20K, and we find R6. So for newcomers to the stream, just show you. Actually, maybe I can. For this purpose, let me add the browser. Okay, maybe not. Browser too. Oh, we shouldn't use, not browser, but we should add window capture. So let's grab that Firefox screen. Just gonna put it underneath me. Oh, that's very small. Maybe up here. Then I can zoom in a little bit more. Like that. That might work. And I think I can almost see on my own screen R6. So 20K ohm on R6. So we had R6 right up here. That was the nice little line of resistors right there. Like so. Oops. Excuse me, I got a text. Okay, not urgent. R13 is the next one. 20K. I think just for fun, let's make sure that DDKey sent me the right resistors. For funsies, let's try the or test the resistance. Okay, 18.7 kilo ohms. I think it's a little bit low, but I suppose it's close enough to 20K. Oh, good night, 50 Shades. Thanks for joining. R13. Oh, we put it. Wait a minute. Let's make sure we don't make a mistake here. So it's a little bit ambiguous here. What is R12 and what is R13 right here? Right. I think the bigger silk screen outline here is for C10, I assume. But we do have these this row here, right? Where oh yeah, it's going down. Okay, so this is R12, obviously. So because R16 matches with this one, C11 goes here, R15 goes here, R14 here, R13 here, R12 here. Okay, so R12. So let's make sure that I don't mess that up. So I think it's correct then. R12 we put in earlier. We can measure just to make sure that we got it right. But for starters, let's put this in R13 here. That's 20K. Should be fine. Oops. Let's see. Not a great. Yeah, I get anal about the alignment. Okay, I guess that's good enough. R12 is a little bit bigger. R12. So just to check, that was a 10K. Let's make sure that we have a 10K resistor right up here. 9.88 kilo ohms. So I think we have the right resistor in the right spot. Let's keep working on the 20Ks. So we had R6, we had R13, and then R14 is next. Oh, Paul, you're in Scotland. Thanks for calling in very early in your morning. Over here in the American Pacific Coast, it's a healthy 7:40 in the evening. And that's a resistor pack, not related, R6. We installed R6. Okay, so I think that's it for the 20Ks. Let's do the 150 ohms next then. That could be a little bit tricky to find, maybe. 150. Oh no, that's the one. Half a watt. Interesting. Okay. Oh, it says there half a watt, so that's good. We have the right. I think the higher the wattage, well, obviously the more watts it can endure, and they're typically larger packages. So we're expecting more currents on that one. So that's R39. Right down here. So yeah, that's a bigger outline on the silk screen. Let's see if we can get a good fit on that. So yeah, I do remember, I'm quite familiar with this particular area of the board because that's where there was a lot of battery damage on the original. So I had to rebuild a couple of traces and fix a couple of VS and replace a bunch of these resistors because they were in pretty bad shape. Right. And 10.5K ohm. 5K. That's R21. R21 is a little bit further up. Yeah, it's right there. Like so. Okay. Fit right in there very nicely. And then we have, yeah, so see, most of these resistors are 1/4 watt, which is why they are smaller packages. But yeah, the occasional ones are just a bit bigger. 1 mega ohm. 1 mega ohm resistor 25 and 37. Okay, 25 and 37. Five sits right over here. Resistor 25. Have to be careful not to put the R's into the C's, so some of the numbering is similar, but for capacitors, since it's possible to make mistakes that you don't want to make. So resistor behaves differently from a capacitor. Right. Something like that. I don't like how one of the legs is much longer. That's much better. What was that? 37. 37 is it's down there. So yeah, is it fun to watch somebody fit a bunch of resistors into a PCB? Next is 680 ohms, should be easy to find, I guess. 680 R15, that's the one. R15, it's up here, right? Yep. Like so. Next up, 3.3K, 3.3K, R22, 43, 41, 18. Let's start with 18 then. Although I only have one in this baggie. I think this is what's one of the components that were shared with the motherboard. So we probably have one more bag of those. R18. R18. We have R19 right there. R16. But over here, there's R18. So R19 should be not too far away. Sorry, R18. We have 19 over there. Where's 18? Oh, yeah, okay. Sorry. Yes, it's R18. Next baggie. 198 ohms. Sorry, 698 even. 698. That's R20. R20 is this row down here. Looks okay. And then we have 22K. Interesting. No hit on 22K ohms. So not sure what's up with that. Maybe there's the actual value is slightly different. So let's put that on the side, and we'll figure out later by looking closer at the schematic. 330 ohms. 330. 24 R4 and R24. But you only have the one. Interesting. Oh no, 330. Okay, 330 and 330K. Just 1,000 times higher resistance. So this is 330 and R4. So that's up here. Next up, 5.1K. That goes into R10. Which is right in the middle here. Beautiful. Next up, 80.6K. 80.6. Okay, that's another one that's not obviously evident from the schematic, so we have to get back to that one perhaps. Next up is 1K ohm. Bunch of them I think we need for that. R27 if we can start with. R27. It's right over here on this side. the other one was R47. R47. It's right down here by the edge connector. Oh, hi, Amina Amine and ALDO2. Oh, thanks for joining. R47. I'm gonna try and get these legs at a decent angle. It's hardly a precision job when you're just using your fingers to squeeze them into roughly the right shape. Have one more 1K ohm. R16, we did that, right? R16, R17. We did not do R16, okay. R16 is right here. See if we have any more 1Ks. R36. R36 is down here. Let's put it this direction because then the brown stripe on R37 lines up with the brown stripe on R36. I'm all about making these resistor installations look just a little bit neater. R42. It's down here. Oops. And then last baggie in my stash, 39K. 39K. On R5. Just the one. Yep. It's right up here. So we finish up this row here. So yeah, let's get the red stripe on R5 to line up with the red stripe on R6. There we go. So let's see which resistors we haven't populated now. We haven't done R1, R2, we haven't done R3. We don't have R19, R23, R24, R30. Actually, there are a lot of them. So we're definitely missing resistors here. Let's see. Let's go the other way around and see if we can find R1. Yeah, we don't want R10. R18. Ah, there. R1 is 150 ohm, which is neither of these. Let's check my little box again. Oh, oops. Sorry. I do have a resistor kit just in case. We can use those, but I think these are probably not the best quality. So I'm just gonna check my bag again to see if I just overlooked some resistors. I'm gonna start throwing out the capacitors here. Let's get ready with the capacitors. Let's put in the cap trimmer soon as well. The little potentiometer, I think it is. But we just have crystals and IC sockets and more crystals and more IC sockets. Oh, here we go. Maybe. Oh, we have capacitors. Oh, here's resistor. Okay, so we found some more resistors. Oh, here we go. Resistor, capacitor, diode over there. Resistor array, we'll do that in a moment. Capacitor, okay. So, good, but they were just hiding underneath. So the caps over there. So let's do these baggies. So what did we say? R1 was 150, okay. We had 150. This one. Just the one. It's getting a little bit cumbersome with all the legs behind. Once I've got all the resistors in place, I'm gonna solder them, I think. Next we have 330K. 24. Right over here. Then we have 324K. 324. That's not on the list, so let's put that on the side. And then we have 10K. 31, 32, 34, 35, 38, 24, 7, 8. So, wait. So, is this a special one? 10K ohm, 0.1% quarter of a watt. 10K ohm, 10K, 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 10K. I don't think there's anything special about this one. Okay. And oh yeah, so these are the ones that we actually already fit a bunch of them. It has a different package though than the other 10K ohms that we had. So let's see if we have all of these. So 7, 8, it's right over here. 9 is also here. 11, that was here. 12, here. 31. Yeah, 31, 32, yes. 34, yes. 35, yes. 38, yes. 26, yes. So, okay, so we don't need this 10K. I don't know if this was part of a different kit. Let's put it over here. 40.2. We don't have that either. So that's for later. 160K. That's not on here either. Interesting. So some mystery resistors. Let's go back and reverse look up these. R2. R2 is 47. Huh. That's 47 ohms. I suppose we don't have that. Let's see if I have that in my kit. Yes, I do. So the list, we have it right here. These are the list of resistors I have in my kit. Quarter watt plus minus 1% tolerance. And here they are, blue package. So yeah, let's grab some 47 resistance. So R2 needs one of those. So what I don't quite like about these particular resistors is that the legs are pretty thin compared to the ones I sourced from DZKey here. Should be fine, I guess, for a logic board, but yeah, not super high quality. Any other 47? R2, R3 is 47 too, okay. Look at the paint job on that one. It looks so messy. R17 is also 47. I really don't have that one. Yeah, I guess not. R17. Sits over here. R28 or 28 is also 47. This one. These are 47K. R23 is 47. R40. Good thing I had a lot of these. Yeah, so somebody watching now or later, please tell me if using these kinds of low quality resistors with very thin legs has a negative impact on the operation of this Lisa IO board. Okay, that's all for our 47 resistance. 47 ohm resistance. Moving on, so we have R1, R2, R3, R4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We are missing 19. Let's see what 19 needs. R19. It's 28.7 kilo ohms. 28.7. We have 40. We have 324. We have 18.6. We have 22K. So none is 28. 28K. Do I have 28K in my kit? I do not. So that's a problem. It's kind of an unusual value, and it's definitely frustrating that it wasn't part of the order. Oh. These are the 10Ks. So that could be one that we need to steal from the original IO board eventually. I'm gonna make a note of that. Lisa IO board parts to steal R19. And I think with resistors you can always hook up several resistors in parallel to get a different resistance. So you can always finagle it that way. At least I think there's, in most cases, there is always a bit of a wiggling room that you can kind of adjust, have a little bit higher or lower resistance. But anyways, 2021, 2023, 24, 25, 26, 27, 28. We're missing 29, 30, 33. 29, oh, that's 29, 30, 33. 29 is an IO resistor. Oh, so they are not connected. Interesting. I wonder if they are not populated on the original board. Oh, let's bring that out to compare. And they are not. So we don't need to populate our 29, 30, or 33, which is nice to know. But all the other ones, look at the bodies are so different. In the old board, it's kind of like more of a mix and match of different styles. I've always liked the aesthetics of resistors since I was a wee lad, opening up all the electronics and looking at what it looked like inside in the 80s and 90s. Oops. So let's move on. We have 34, 35, 36, 37, there's 38, 39 over here. Then we have 40s right there. There's 40, there's 41. Is that populated? 41 is not populated. Well, look at that. It's actually, it was installed probably in the factory, but it got snipped out. So I guess Apple engineers changed the design at the last moment. Had the factory just snipped that one out. 42, 43 is over here. 44, not populated. But it is on the original board, so we need to find this one. R44. That's 47K. $47K, 40K. Nope, we don't have 47K. But my kit does have it. 47K. pop one of these out. Right here. R45, 46. Also, let's see, empty. Let's check the original board, 45, 46. And they are certainly populated. This is down here where the brunt of the battery damage happened. 45, 46. R45 is 47K, or 46, 1K. Oh, so we need to steal one more 47K from the kit. Goes into R45. And 1K, I'm pretty sure we had in the bags here. We have 10K. Sure, we had 1K. We have 10K. Cap ceramic, cap. Huh. So either we're low on 1K, or at least remember. So let's take 1K from the kit. There we are. We used up quite a lot of the 1Ks. Goes into 46. Alright, so moving down the line, 46, 47 is down there. And that's it. So I think we have everything except that one with a weird value, R19, and we will steal later. So let's proceed. I'm gonna demonstrate now. So this is what it's looking like on the underside, like a lot of little legs sticking out. So let's go ahead and solder all of those. So let's see if I can. I don't even know how this is gonna be fun to solder. Let me just do it like this, because this is gonna be in the way. Let's turn on the fume extractor and let's go crazy on this thing. part is always to solder these in a way that you don't mistakenly create bridges and kind of solder legs together with other neighboring legs and make a mess. But this board is pretty roomy, so there's plenty of space to work with. There. I think we have all the resistors soldered. So let's go snip snip. I can find my tool. The hardest part with this job is to clean up all the legs afterwards. And it'll be all over the room. Don't want the dog to eat them. So it's when you do this larger job that when you start appreciating surface mount electronics. That's why they may be fiddlier to work with surface mount. Once you have a technique down, the act of soldering becomes much more streamlined. So yeah, there's a lot of waste with these legs. So I think when I'm done with these resistor legs here, I might wrap up this stream fairly soon. We've been going for an hour and a half, and I have some things to take care of at home. But I'll keep streaming this project because yes, I only have about a week left now before I have to move, and I want to finish this job. Whew, so many legs. Snip, snip. Whew. Okay, I missed one here. No more legs. And a bunch of resistors. So that was fun, kind of. It's a fairly relaxing job to just go around placing components like that. I will next time I will keep going with the capacitors, of which there are a fair amount. There's a bunch of bypass caps around the logic chips and stuff that needs to be taken care of. So about a similar sized job, I think, with all the caps, as with the resistors. So, and then it's all the sockets. So, and that's pretty much it. There's a couple of special coils or whatever. So, thanks you all for watching. Thanks for the chats, and I'll wrap it up there. Have a great rest of your day.